Gastaporani. Nijadina. Yeah, Siyajabulu Udi Border and Michael House. Okay, I'm Kelly. Guys, today we're going to be working on helping you prepare for your test. When do you write your test? 16th September, okay. So like that's what, Monday or something? Tuesday? Monday? Yeah, Monday week. Okay, not this Monday, next Monday. Okay, these are the topics, right? When the teacher, they get told by the government, by the Department of Education, well, the department, someone in the department sets the test, but those are the topics that we're going to look at, okay? So those are the topics that are in the workbook. I'm sorry, today the workbook, I don't know why, but the numbers for the pages aren't there. So we're just going to have to find the page that we're working on. That'll be great. Right, guys, we always just start with a prayer. Keep this call, and this is the starting prayer. Thank you. Close our eyes, thank you. Dear Lord Jesus, we just thank you for this opportunity to be together today. Pray that you bless our time together, and that we would learn a lot, and that we would have fun. We ask all these things in your name. Amen. Right, guys, we're going to start off with financial maths, which is at the beginning of your book, and you'll see that it's actually the biggest topic along with probability. So we'll do financial maths first, and then we will do probability after that. Okay, right. I see someone has joined us online, which is great. Okay, so if we go right to the beginning. Okay, and we're going to start off. Justin's going to walk around. He's going to take some answers from you guys. Guys, percentage. It's like everything in financial maths rests on percentage and an understanding of percentage. I don't know if you guys know, but how many of you do science? Oh, there's some people in the room who do science. Yeah, so there's not lots, okay, but there are some of you that do science. So in science we talk about an SI unit, but the percentage is almost like it's a global, it's a globally understood form for a fraction. Remember, a percentage is a fraction. It's just a fraction out of 100. Okay, so 70 out of 100, 70%. Okay, and we will come across percentages everywhere. People will talk about the percentage profit. People will talk about the percentage chance of something happening. When we do probability, you don't hear the person on the TV, you don't hear that person saying, tomorrow there's a 17 out of 28 chance of rain. Okay, they say there's an 80% chance or 20% chance. So people understand percentage. Right, I want you to quickly just fill in this little table. These are decimals, these are percentages. Norma, these are percentages, these are decimals. All right, and I'm going to ask Justin to come around. Justin's got some, I'm a sweetie, I'm a mahani, and if you give the right answers, he'll give you a sweetie. Okay, so let's have a look. The first, anyone answers for some of them, yeah, so Justin's going to start. Justin is also in grade 11. He's in my grade 11 class.
Good morning.
Hi. Okay, do a few more while you've got it.
Okay.
Halala. Well done. Okay. Okay, you mala. Okay, well done. Halala. Okay. It's unbelievable that you can convert from decimals to percentages, but also from percentages to decimals. Okay, so now we're going the other way. All right, and Justin's looking for someone. Yes, here we go, right at the back. Maybe guys, when you just just, if you take a question, just tell us your name, okay? Just Igala, you don't even have to tell us what school you're from. You can say, I am Paul, morning, I'm Paul, and the answer is, okay?
Okay.
Cool.
Yeah. 0.8. Next one is 9 times 10 to the 1
Did you use a calculator for that?
Yeah.
Okay, guys, I want to talk quickly about a calculator, okay? A calculator is useful, and you're going to see I'm going to use my calculator today. But we don't want to use a calculator for stuff that our brain should be able to do. Our brain is like a muscle. If you go to gym and you pick up a weight and you do this all day, what happens to your arm? It's going to get stronger. Okay, your brain is exactly the same. If you use your brain, then it's definitely going to get better. I'm interested in the learner here who gave us the other answers. Did you use a calculator or not? You didn't use a calculator. Okay, great. Guys, let's try and do it without a calculator, okay? Because these are not big numbers, and we need to be able to do this. So the answer that I got was 9 times 10 to the minus 3. That's correct, okay? But how am I going to write that as a decimal? 0,009. Okay, because remember 8% was 0,08, so now this is one decimal further. In maths, everything's connected to everything else. We know from our exponents that this means 9 over 10 to the positive 3, am I right? So that actually means 9 divided by 1,000, okay? So if we look at our 9, when we divide it by 10, it becomes 0,9. When we divide it by 100, it becomes when we divide it by 10, it becomes 0,9, by 100, 0,09, and then 0,009, okay? All right, okay, and 108%, while you've got the microphone. Hello, well done, and 92%. Yeah, and then 500%. 5, well done, okay. All right, okay. Now, guys, I'm going to show you something today, right, that I think is a very useful way of converting, of growing things by percentages and working out discounts, etc. So if I asked you to increase 700 by 6%, I think if we were going to work it out, we would work out 6% of 700, am I right? And then what would we do? We would also add 700. Am I right? So this piece here is the increase, and this is what we had initially. Okay. Now, I want you to write that down, and then I want you to write underneath it, let's take out 700 as a common factor. Okay, we've done factorizing. What must I have in the bracket if I take 700 out? What must I have for this first term? Just a 1. And then here I must have 6 over 100, but let's change that to a decimal. 0,06. Okay, so what we're going to do, we're going to multiply 700 by 1,06. All right? 1,06 is actually, what's that as a percentage? It's 106%. So we are finding 106% of 700. And that's growing it by 6%. Does it make sense? It always makes sense. I didn't hear many people say yes. Okay. Guys, if you multiply a number by 1,06, you are growing it, you're increasing it by 6%. Okay? I'm not really worried about the final answer here. This one's actually 742. Okay? Right. Let's do the next one. We want to increase 250 by 12%. I'm going to do it like I did the last one. I'm going to do it slowly. Well, let's work out 12% of 250. And then we must also add on 250. Is everyone understanding why we're doing that? This is the increase, and this is what we had initially. Like I did last time, let's factor out the 250. And what do I get inside? 1 plus 0.12, which is actually 250 times by 1.12. And guys, this multiplier will increase 250 by 12%. Okay, I'm just looking for a calculator because I'm going to need a calculator sometime soon. Okay, there it is. Right. What's the answer when we multiply 250 by 1.12? How much? 280. Okay, great. Thank you. All right. Justin, I'm going to need you to make a plan with that door. I don't know what plan. You could close it, or maybe get that rubbish bin and prop it against the door. Thank you. All right. Now, guys, what about? Let's see if we can go straight here. Remember that this is 112%. Okay. If I want to increase 300 by 20%, what multiplier would I use? Who can tell me? In other words, what number could I just go straight away if I want to increase 300 by 20%? What could I multiply by? Okay, I'm going to ask Justin to see if anyone's got their hand up. So I want you to look at what happened before. When it was 6%, we multiplied by 1.06. When it was 12%, we multiplied by 1.12. For 20%, what are we going to multiply by? One comma two. Guys, 1.2 is the right answer because that is 120%. Are we okay? Okay, and the final answer when you do that is 360. Okay. Underneath here at the bottom, in each case, our multiplier has been bigger than 1, all right, because we are increasing. When you multiply a number by a number bigger than 1, you are increasing. And that's why, guys, all these multipliers that I've written down, I've shaded in green, okay, green for increasing. Now, we're going to do another example. To Pedulikas. Okay, now we want to decrease 600 by 10%. I'm going to do exactly what I did before. I'm going to work out what's 10% of 600. What's 10% of 600? Guys, you should know that. 60, eh? Yeah. But now I'm going to take that away like that. Right. This is the amount I'm decreasing by, and this is my original amount. If I take out a common factor, what am I going to get here this time? 1 minus 0.1, okay? And 1 minus 0.1 is 0.9. All right. And 0.9 is my multiplier. Now, the reason I'm using a red pen now is because this multiplier is less than 1, and we are going to decrease. But what is 0.9 as a percentage? 90%. Do you see why we started, when we started with this table here, okay? That's 90%, all right? So if we decrease something by 10%, then we must just multiply it by 90%. Does it make sense? We're finding 90% of 600. Okay, our final answer here, I'm not worried about the answer really, but our final answer here is 540. Can anyone tell me, and maybe we can do it straight away, what multiplier must I multiply 300 by? I'm going to ask Justin to look if anyone can put their hand up. And I'm going to make it a red multiplier, but what multiplier must I multiply 300 by if I want to take 20% off it? I want to reduce it by 20%.
So
Hala, 0.8. Guys, because what is 0.8? It's 80%. And if we are taking away 20%, then we want 80%. Does it make sense? Hala, it always makes sense. Okay, guys, the answer for this one is 240. Do you see how we can find these multipliers? Now, I want someone now to tell me, what must I multiply 90 by if I want to decrease it by 6%? Okay, so we've got an answer right at the back. Justin, you have to go long walk. Justin's going to get very fit today. Okay, learner from Nyezaleni. Just tell us your name and then tell us what multiplier should we use if we want to take 6% off 90.
My name is
Hala, well done. 0.94, guys, because that is 94%. And so we wanted to take off 6%. So if you've got 100% and you take off 6%, then you're left with 94%. Okay, I don't know the answer to this. I'm going to have to work it out. I can't do that one in my head. The other ones I could do in my head. You see, I'm only using a calculator when I need to use a calculator. And that's why my brain is getting better every time. All right, this one is 84.6. Right, when we are decreasing, our multiplier is less than 1. Okay, so on this page, every time I've had a multiplier which is decreasing, I'm shading it in red, and when it's increasing, I'm shading it in green. Okay, so now let's have a look at this. Now we're going to answer some questions, and I'm hoping now you're going to see why these multipliers are useful. The price of the share drops by 20%, and then it increases by 20%. Now, guys, you can ask lots of people, educated people, people with matrics, people with degrees, and they will get this question wrong. All right? Most people will say, it won't make any difference because if you increase it by 20% or you drop it by 20%, then you increase it by 20%, you're back to where you started. That's not correct. Okay? It's going to be different. Let's do it with a multiplier. Okay? This P, I'm going to just let that be the price. Okay? So the price is P. What multiplier must I multiply by to drop it by 20%? And I want someone to put their hand up. All right? And then I'm also going to look for someone to give me the multiplier to grow it by 20%. Okay, so just put your hand up so Justin can find you. To drop it, yeah. Hi. Hi.
To drop it by 20%.
Allah, well done. Find someone close by to this gentleman. He's 100% correct, guys. That will drop it by 20%. Do you see I've made that a red multiplier? Huh? It's less than 1. We're dropping it by 20% because this number that we were given here is actually 80%. Okay, now, what multiplier must I use to grow it by 20%? One comma 2. I did see you looking at your calculator. I know, but well done. All right. Now, guys, let's have a look. Let's multiply those two multipliers. Okay, so you can do that on a calculator if you need to. You might know what 8 times 12 is. 8 times 12 is 96. Okay, so in fact, if you multiply the multipliers, it's going to be 0.96. Guys, must I use my red Koki or my green Koki to highlight this multiplier? The red one, Ibongo, okay? Because it's less than 1. Right, now, who can tell me, looking at this multiplier, because this multiplier is the combined effect of these other two multipliers, what has happened to this price of the share? Has it gone up or has it gone down And how much has it gone up or down? What percentage? Yeah, we've got an answer here. I think this is our friend who answered our very first question.
My name is Jan Tom. The price has been dropped down by 0.04%.
Not 0.04.
Okay,
So, by
by 4%.
just 4%, yeah. Guys, it's dropped by 4%, huh? Are we okay? Not 0.04. 0.04 is like a tiny amount. What number is this? This is 96%, isn't it? Okay. Do you see how important it is for us to be able to read decimals as percentages and percentages as decimals? Okay, now, this question here, again, you can ask lots of adults and they will get this wrong, okay? Because what it says is an item costs 490 Rand after a 20% discount has been offered. So then it says, what did it cost before the discount? Now the reason people get this wrong is they start working out 20% of this number. Kodwa, akunjalo neze. The 20% was not worked out on this number. The 20% was worked out on the original price. Okay? So if the original price is P, what multiplier will reduce it by 20%? What multiplier will reduce it by 20%? Let's get an answer. Thanks, Justin. Gus, to drop it by 20%. Yeah, we've seen this one already today a few times. So, 0.8. Hala. And guys, when we multiply our price by 0.8, we get 490. All right. Mind you, we've got an equation. Okay? Maths is all about equations. I'm sure I've taught you some equations maybe earlier in the year. You might have seen, if you look at Justin's shirt, on his shirt, all the My Class boys on their shirt have got a scales. Okay? Scales are a great way to describe equations because an equation is balanced, and as long as we do the same thing to both sides, it will remain balanced. If we add 5 on the one side, we must add 5 on the other side. Okay? Now, Andifuni P times 0.8. I just want P. What must I do to both sides to get P? Well done. I must divide by 0.8. Okay, maybe we can just get that on our calculator. 490 divided by 0.8. 490 divided by 0.8. 612.5. Okay, now, guys, it is important because this is financial maths. We must always write our answer with 2 decimal places. Okay, so 612 Rand and 50 cents. Now, Penduli Kasi, I'm going to ask you guys to try this next one. And I want you to try and do it the way I did it, with a multiplier. So, if the original price was P, I want you to think about and set up an equation with a multiplier. And I will tell you that the multiplier will be a green multiplier. Okay? And then I want you to tell me, what did this thing cost before the VAT? So I'm looking for someone to put their hand up and tell me, what equation are we going to solve? Okay?
So our equation will be P multiplied by 1,15 is equal to 102,35.
100%. Hala. Okay, guys, there's our equation. Because the price is being grown by 15%, that's 115%, this number over here. Okay, and so And now, while you've got the microphone, just tell me what you got what did you do next?
So one left, we go speak by, then we divide by 1,15 both sides.
Okay, so we're going to divide by 1,15 on both sides. What did you get as your final answer? 89 Rand. Hala, well done. Okay, all right, guys. This is a very good way to do these questions. You need to take my word for it, because a lot of people get confused as to, they start trying to work with the 15%. I want you just to try and always think about a multiplier. Right, let's look at the next one. This question says, the price of a share drops by 10%, and then it increases by 20%. And it says, would it matter if it increased first and then dropped? Now, let's have a look. What multiplier must I use? Suppose the price is P. What multiplier must I use to drop it by 10%? Let's all say it together. 0,9. Hala. Notice, guys, that's a red multiplier. Okay? 0,9. What multiplier must I use to grow it by 20%? 1,2. All right. 1,2. Okay. So that times that times that. Now, if over here on the other side, if I want to increase it first, I will multiply it by 1,2, which is a green multiplier. And then I will multiply it by 0,9, which is a red multiplier. Are these things the same, this one and this one? What's 3 times 7? 21. I hope more of you would answer that without a calculator. 3 times 7 is 21. 7 times 3, 21. It does not matter in maths what order we multiply numbers in. So these are exactly the same. Makes no difference. Okay, now, on Wednesday or Thursday, I can't remember, Wednesday, I was teaching Justin's class this, and I kind of got confused, but the best way to explain this, right, guys, is this. So an item goes from 300 Rand to 285 Rand. What I want to work out is what multiplier was used. And it doesn't matter if it's increased or decreased, we'll see that just now. So I'm going to go 300 times by a multiplier comes to 285. Okay, I didn't explain this very well the other day. This is a better explanation. So guys, what must I do to find the multiplier? I must divide both sides by 300. And can someone tell me what is that multiplier as a decimal? You can just someone yell. 0,95. Thank you very much. Now, guys, is this a red multiplier or a green multiplier? Red. And what has happened? How much has decreased by if that's my multiplier? Well done. It's dropped by 5% because it was 100% and now it's 95%. Okay, I want you all to try the next one, which is exactly this. It's dropped by 5%. Sorry, 5%. I want you all to try the next one. And again, I want you to write the start price, multiplier, times the multiplier, and then the end price, and then work out what the multiplier is, and then tell me the answer, the final answer. Okay, put your hand up if you're ready to give Justin an answer. Okay, I want you, before you do that, okay, because the thing is that I want us all to learn this together. What are you going to write down as an equation if we do it like I did the other one? So we start off with 200. Did you say 200 equals to 475? 200 M, yeah. Guys, I'm using M for multiplier, okay? You can use any variable, but I'm just using M, multiplier, okay? And now what are we going to do? Well done. Okay, 435 divided by 200, okay? And what did you get when you do that? 2,375. Okay, is this a green or a red multiplier? It's a green one, okay? Now, do you know what percentage it increased by? Okay, this is a little bit tricky. Okay, it's the very last one of these that we're doing. What percentage did it increase by, guys? Yeah, if this person gets it wrong, then just in front, yes, okay? Okay, that's not correct. That's not the percentage increase. Did you have the same answer or did you have a different answer? Okay, it's not 37,5. At the back, yes, Andy, we've got some answers there. Guys, this is important, because it's a little bit trickier, because normally we've just got 1 comma something. Okay. Okay, no, it's not that. This number is correct, but we just got to get this to be a multiplier now.
So the answer is 2.38%.
No. Okay. All right, we're going back to the back. Sorry, Justin. Yes. 137,5%. Hala. Okay. All right. Now, guys, the reason it's 137,5% is because, remember, when we had a multiplier of 1,2, this 1 represents the original value. Okay. So in this 2,375, there's already 1 which is the original value. I'm going to do a simple example here. Suppose I take the number 7, okay, and I increase it to 14. All right. Now, if I work out what multiplier I use, okay, I get what? I get 2. Ah, man. Sorry, guys, 7m equals 14. So m equals 2. Now, guys, that is 200%, okay? But that's not the increase, because there's already the one of the part of that 2 is the original value of the 7. Okay, so it's actually 100% increase. So with the ones that are bigger than 1, all right, like 2 comma something, you need to subtract 1 always. Even here, you subtract 1. If your multiplier is 1,2, it's not 120%, it's 20%. So we in fact, all along, we've been subtracting 1. So when it's 2,375, that's actually 237,5%, but we need to subtract 1, it's 137,5%. Okay, right, let's now get into just some ideas with proportion, okay? And you might be saying, Paul, we're spending a long time just dealing with numbers. When are we going to get into the formulas? We're going to get into the formulas soon. Okay, in maths, and especially in life, when we are working things out, when we work out how much petrol we're going to buy, how much paint we need to buy, anything like that, how much fertilizer we need to buy for a field, it's all about what we call proportion. Okay, and I want to just show you, again, I want to show you a method of solving problems that involve proportion. Okay, so what we've got here, we've got 30 liters cost 750 rands. And then the question says, what will 18 liters cost? Okay, now, that's not obvious, okay? I know most of you can work this out, but I want to show you a method that we can use that will kind of always work. I'm going to ask you on the side here to write down another example. Sweets. Okay? So 2 sweets, and this is the cost. 2 sweets cost 10 cents. Okay. Now, if I say to you, what will 3 sweets cost? All right? Now, maybe I might say, well, I added 1, I must add 1. Is that right? That's not right. Guys, you don't add 1 and add 1. When you add 1, you are destroying proportion. The only thing you can do with proportion is to multiply, norma, divide. Okay, so this is rubbish. Alright. If I want to know what 3 sweets cost, okay, what I can do is I can divide by 2 on this side, and I get 1. But if I divide by 2 here, I must divide by 2 here. What does 1 sweet cost? 5. Now, I don't want to know what 1 sweet costs, I want to know what 3 sweets cost. What must I do here? And I cannot add. Don't say, Paul, we're going to add 2. What? I must times by 3. And if I times by 3 here, I must times by 3 here. Does it make sense? It always makes sense. Okay, Justin knows that from class because I tell them that in class. Even though they're all speaking English, I'm trying to teach them some isiZulu. Okay, all right, guys, what are we going to do here? We want to get 18 here. This is difficult to know what to do. Kodwa, to get 1 will be easy. What must I do to 30 to get 1? And don't say, Paul, we're going to subtract 29. What are we going to do? Well, we're going to divide by 30. If I divide by 30 there, I must divide by 30 there. Okay. And guys, when you divide by 30, okay, you have to get 25 here. Okay. Now, what must I do to get from 1 to 18? Multiply by 18. Okay? If I multiply by 18 here, I must multiply by 18 here. Alright, and I get 25 times 18. I think it's 450. Okay. Alright. Now, there's another question here. It says, how much petrol can I buy with 1,000 Rand? Okay? So what I'm going to do is I'm going to put 1,000 over here. I've left a line. And the reason I've left a line is because I want to get 1. 1 is the useful number. All right. And I could go from the top row. If I wanted to go from the top row to 1, what must I do? Divide by 750. Norma, I can even go from this row. I must divide by 450. If I divide by 450 on the right-hand side, I must divide by 450 on the left-hand side. And so I'm going to get 18 over 450. I'm not even going to do that. That's just a number. How do I get from 1 to 1,000? Times by 1,000. If I times by 1,000 on that side, I must times by 1,000 on this side. And so I'm going to get 18 over 450 times 1,000. Can anyone tell me what's the answer to that? How much? 40 liters. Okay, right. Now, in your financial maths, one of the things that you need to be able to deal with is exchange rates. These questions, you do exactly the same way. So this question tells us that 250 Rand is $13.83. Okay, so you just make a little table. The one column you put rands, the other column you put dollars. Now, it says, how many dollars is 800 rands? So I want to get 800 here. Guys, notice I'm not writing 800 here. I'm writing 800 here because I want to get what here? 1, hala. I want to get 1 there. Okay? And once I've done that, I want to get a 1 here because I want to get $500. Okay? All right. I'm hoping someone can tell us just now how to get to the $800 and how to get to the $500. Well, that, guys, you'll notice now, I'm not even going to write the divide by 250. I'm just going to do that. Okay, and then what are you going to do? Well done. So we've got this number, 13,83 over 250. Guys, I'm not doing this on the calculator yet. Now I'm going to multiply by 800. Okay, and what's my final answer? Have we got an answer or not yet?
It's 42,18.
Okay, well, we're right. Guys, is that what people got? 44.
It's 44,25.
25. Okay, 26. 256, so it must round up to 26. Okay, cool, thank you. Right, let's get someone else. How can I get, and it doesn't matter which row you use, you tell me where you're going to go. In a way, it's better to use the original information you were given. How can I work out how many rands is $500? Sorry, so just say that again. Which number am I going to multiply? I want to get a 1 here.
Yeah, we're going to multiply by 13,83.
Are we going to multiply or divide? Yeah, we're going to divide by 13,83. Now if I divide there, I must divide here as well. 250 over 13,83. Okay, and then what are we going to do to get to the next row? We're going to, by what? By 500, yeah. Hala. Okay. And guys, I'm going to quickly do that on my calculator. So it's going to be 250 over 13,83 times by 500. And I get 9,038, and I must round to 2 decimal places, 9,038 and 32 cents. Okay, all right, guys, I'm hoping you found that method useful. Okay, we're now going to dive into some financial maths examples, all right? And we've got 4 formulas, okay? The ones on the left are appreciation, where something gains value, all right? There are 2 types. There's simple interest and compound interest. But both of them, our A value ends up bigger than our P value. And I want you to look, in both formulas, you've got a plus sign. And that inside there is a multiplier, okay? All right? So it's bigger than 1. The other 2 formulas are for depreciation, where something loses value. And now A is less than P. And both those formulas have got minus signs in them. These 4 formulas get given in tests and exams. On the exam, there will be those formulas. What they don't tell you is the names for them, okay? So especially with depreciation, there are 2 types. There's what we call straight line depreciation, and there's reducing balance depreciation. Okay, so 2 different types. Okay, And then just a little thing is that inflation, unfortunately, inflation is always compounded, so we're going to use that formula, and it's always annually compounded. Okay, now, what we're going to look at now, all right, we can compound interest rates at different intervals, okay? So, and I'm going to show you two examples here, all right? And I'm just going to ask you to write this down. R1 for 1 euro. Okay, so what this says is we go to the bank and they're going to give us 10% per annum. Cordwa, they're going to compound it monthly. And what we want to know is what does that work out to at the end of the year? And it will be more than 10%. Okay? And we'll see now. I'm going to do two calculations here. This here, I'm going to take my R1. I'm using this formula here. A equals P 1 plus I to the N. I'm going to take my R1 and now I'm going to take my interest rate. Now my interest rate is 0,1, that's 10%. We're okay with that? And I'm going to divide it by 12. And in 1 year, how many months are there in 1 year? 12. So my interest rate will be worked out 12 times. So my R1, I can work out what that R1 is going to be. Now, and I'm going to use a different color here, I'm going to use the green pen, and I'm going to talk about an effective annual rate. Okay? All right. If I go to the bank and they give me an interest rate for my R1, and they say, we're going to give you the effective rate, that is going to be the interest rate that they're going to apply just once. All of that on one occasion. So when you divide it by 1, it stays as it is. Okay. How many variables are in this equation now? Any order, just one. There it is over there. Okay. Now let's work out what it's going to be. All right. So on the left-hand side, if I use my calculator, I've got 1 plus 0,1, 12 to the power of 12. I've got 1,1047. And on the right-hand side, I've just got 1 plus I. So if I subtract 1 from both sides, I've got I is 0,1047. What is 0,1047 as a percentage? And you remember the very first thing we did today. What percentage is that? 0,1047. 10,47%. Right, now that, guys, that is called a nominal interest rate. Okay? Per annum, but it's a nominal rate. Sorry, rubbish. Sorry, it's not a nominal rate. That's an effective rate. Okay, this is a nominal rate. Okay, and what you'll notice is that the effective rate is bigger than the nominal rate. So just understand what we're saying here. If you go to the bank, let's say there are two different banks, okay? And Standard Bank says to you, we will give you 10% per annum, compounded monthly. That's exactly the same as if you go to Capitec and they say, we will give you 10,47% Cordwa at the end of the year, just once. Same deal, exactly the same deal. You'll get the same amount of money out. Okay, now I want to go the other way, all right? And again, I want you just to write down here, just to remind you what we're doing here. R1 for 1 year. Okay, So now this says, what annual rate compounded quarterly? This is a nominal rate. Will return the same as 10% per annum. This is an effective rate. So all we're going to do is we're going to make an equation, all right? I don't know what the interest rate is. Suppose it's, so here's my R1. Guys, I'm using this formula. P is 1. 1 plus my interest rate, guys. But if it's compounded quarterly, what must I divide it by? 4. And how many times will it be worked out in the year? 4. Okay. So that's how much money I will have on R1 in 1 year if the interest rate is I. On the other side here, I've got an effective rate of 10%. That is just going to be 1 plus 0,1. It all gets worked out on one occasion, only once, like that. How many variables have we got now? Again, only 1. Okay, I'm just going to use a highlighter here. This here, all right, is this. Annual rate compounded quarterly. And then this here is 10% once effective rate. Okay, so an effective rate only gets applied once at the end of the year. Right, now, this is a little bit more difficult because the I is inside there. Can anyone tell me, remember our equation is like a balance, like a set of scales? What can I do to both sides? Okay, Justin's going to look for someone. What can I do to both sides to get rid of that power? Yeah. Huh? Okay, so it's saying like the fourth root on both sides, okay? And he's absolutely right, because I'm going to show you how I'm going to show it to you with exponents. Okay, let's just go back to our exponent stuff. If I've got x squared and I put a 3 here, what happens here? Do I multiply or do I add these? Okay, guys, we actually multiply them. All right, it's not add, it's multiply. So now, what I want to ask us, if I've got something here, and I want to get rid of that power of 4, what fraction must I multiply by to get x to the 1? Well done, 1 over 4. And what you said, the fourth root, or square rooting, okay, square rooting 4 times, I think is how you said it. Guys, if I raise the left-hand side to the power of a quarter, I must raise the right-hand side to the power of a quarter. Okay, so what we've done, we've put a power of a quarter on both sides. On this side, the power of 4 just goes away, and on this side I've got 1,1 to the quarter. What must I do next? I'm trying to find I. What must I do next? I would subtract 1 next, okay? So if I subtract 1 next, then I get I over 4 equals 1,1 to the quarter minus 1. What's the last thing I must do? Multiply by 4. Okay, so I'm going to go 4 to 1,1 to the quarter minus 1. Okay, and I'm going to do that on my calculator because I want to show you guys something here. 4 times 1,1 to the power of a quarter . 4 times 1,1 to the power . Power of a quarter minus 1. Right, and guys, I get that. What is that as a percentage? 9,645. 9.65%. Right. What I want to show you, this is really important. I'm going to store this number because I want to use it accurately. I want to show you exactly what's going to happen here. Right? So I'm going to store this number. I'm going to, on my calculator, I'm going to go Shift RCL, so Shift Store, and I'm going to press A. That's going to store that number in A. Okay, so that exact number is in A. Now, guys, if we've got 100 Rand, listen carefully to this, and we invested for 1 year at 10%, how much money will I have at the end of the year? So it's 100 Rand, if we grow it by 10%, it will just be 100 at 10 Rand. Are we okay with that? What would our multiplier be? Our multiplier would be 1,1. Okay. So with the effective rate, 100 Rand is going to become 100 at 10 Rand. Now, what I'm going to show you is that if I have a rate of 9.65% and I apply that rate 4 times in the year, I'm going to end up with exactly 110 Rand, the same. Okay, so watch this. All right? What I'm going to do on my calculator, I'm going to press 100 equals. All right, when I do that, in the calculator's memory called answer is the number 100. Okay, now watch what I'm going to do. I'm going to take that answer, which is 100, and I'm going to multiply by 1 plus recall A divided by 4. Okay, so just think about what I'm doing here, guys. This is a little bit complicated, but it does make sense. I am going to grow my 100 Rand by a quarter of 9.65%. And that is how much money I will have at the end of the first quarter. I will have 102 Rand and 41 cents. Now, this number, 102.41, is in the calculator's memory called answer. If I press the equals button again, the calculator will do that calculation again, all right, but it will take my 102 Rand and 41 cents and it will grow it by a quarter of 9.65%. So after 2 quarters, I will have that much in the account. This answer is now in answer. So if I press equals again, the calculator will calculate how much money is in the account after 3 quarters. This answer is now in answer. So if I press equals again, the calculator will do that calculation one more time. After 4 quarters, I've got 110 Rand. So understand what we're saying. Getting 10% one time, once got end of the year, is exactly the same as getting 9.65% 4 times in the year. All right, you don't get 9.65% each time, you get a quarter of 9.65% each time. All right, so that's nominal rates and effective rates, but the best way to do it, in my opinion, is to think about 1 Rand for 1 year. Okay, we're going to go now to question 4. All right. And I'm going to ask you guys just to take some time and to look at question 4, question 6, and question 8. Just the even numbers on this page. All right, just work on them. You're welcome to talk to the person next to you, and in a few minutes we will take some answers. Okay. So the first thing you must do is write down which formula you're going to use. Guys, if you just write down a number here, and if you just write down a number, now your teacher's marking this. If it's wrong, how many marks can your teacher give you? This is wrong. How many marks? 0. All right, guys, you can't get any marks if there's no working. So, with all these questions, I want you to first write down what formula. Okay. And then I want you to start using the formula, and then I want you to get your answer. And then even if you make a mistake, you can still get some marks if you're using the right formula. Okay, Justin, do you want to see if someone's got an answer for number 4 for us? Yeah, at the end of your thing, 1 or 2 hands. Okay, so I want you to tell me first, which formula are you going to use? All right? Okay, tell me what the formula is for compound interest. Half it, okay, great. So that's the right formula. So guys, I'm going to mark this as you go, okay? So far you've got this question's out of 4. So, okay, so far you've got 1. Okay, so you're going to put 100 here, yeah? Well done. Guys, that's 12%, 0.12, okay? 60, well done, okay. Guys, that 60 is 5 years, but 5 times 12, yeah. All right, so you've got another 2 marks here. Basically 1 for dividing this and 1 for that, okay? Now, what's your final answer? And is that correctly rounded? Okay, if it's correctly rounded, then you've got your 4th mark. Well done. Guys, I want to just emphasize, if you had written 180 Rand, just 180 Rand, I will give you 0. I'll give you 0 because I don't know what you've done, I don't know how you got it. Okay, learn to show your working. Well done. Allah, Allah. Okay, right. Now, I want someone to do number 6 for us. All right? So, this one is around depreciation. Guys, Justin's going to be doing this work next week in class. So, he's got a bit of an advantage over his friends now. Yes. No, that's absolutely fine. Yeah, so you don't get given that formula. Guys, if you look at these formulas here, all right, you'll see here what it says is n is not the number of years, okay? N is the number of time periods. So in that example, n is not 5, n is actually 60. But it's absolutely fine, yeah. So quite a lot of books use the M as well, yeah. That's fine, okay? You would have got the right answer, I'm sure. Yeah, no problem. Okay, right, number 6. I'm looking for an answer for number 6. This is about depreciation, and it talks about this funny word, reducing balance. Now, reducing balance is going to tell us which formula. All right, you tell me, what formula did you use?
Hello, everyone.
Hi. Hi, Emma.
Use the balance formula.
Which one is that? Tell me what it is.
A is equal to P equal to Y minus I exponent.
Well done. Okay, that's the right formula. You got 1 out of 4 so far. Where is that, A or P? Well done. Okay, guys, A is your final value. So it starts off at 450. This is P, and it goes to that. That's A. Remember, with depreciation, A is less than P. Okay, carry on. Yeah. 5. Okay, Allah. All right, now, what are you going to do now? We've got an equation. I'm changing this to 5 marks, okay? So I've given you 1 for the formula here. I've given you another 2 for putting the right numbers in the right place. Now, this is a bit harder to solve, which is why I've made it 5 marks. What are you going to do next?
Then I say 100,000 divided by 450,000.
Okay, I'm going to do some of that in my head, guys, because that's actually just 10 over 45, which is actually just 2 over 9. Okay?
And then I say into 1.
1 minus I to the 5, huh?
Yes.
Okay? Now, well done, so you've got another mark. Now what?
And then I added the square root of 5 both sides.
Yeah, so what you're actually doing is you're doing one of two things, guys. You're either doing this on your calculator, all right, or you're taking 2/9 and raising it to the power 1/5. Guys, these are the same things, okay? Because that's a rule in terms of how you change a surd with a root sign into an exponent form, okay? And then, all right, so let's just do that. So you're going to go the 5th root of 2/9. I don't actually do this one, I do this one, but it doesn't matter. And that equals 1 minus I. And then what did you do?
And then I ran minus the 1 both sides.
You minus 1 from both sides, and then? Okay, so minus I is going to equal, sorry guys, I'm losing my way a little bit here. Minus I will be the 5th root of 2/9 minus 1, yeah. And then?
Minus I is equal to negative 0, comma, is equal to negative 25,9,97. And then I added those because it's continuous.
So then you?
Negative 0,2597
Okay, so your final answer as a percentage?
is 25,97.
Well done, Allah. Okay. 25.97%. Okay, all right. Okay, now in grade 11, okay, we start doing some financial, some ones where it's a little bit more difficult, where we've got a timeline, okay, all right, and this is the stuff I'm going to be doing with Justin and his class this next week, okay. So this question says, how much must I invest today to have 5,000 Rand in 6 years' time? Interest is that, and then, okay. What we're going to do, we're going to draw a timeline. So we draw a line here, okay? And this is T6. This is in 6 years' time. This is T0. This is today. Okay. And I'm going to invest some money today. I don't know how much. But the interest rate is going to be 12% per annum for 4 years. So I'm going to put T4 here. All right? And I'm going to show you how I can write that. I'm going to write that as I with a little 12 in brackets. That doesn't mean I to the power of 12. It means interest is going to be calculated 12 times. All right? And the interest rate is 12% per annum. That happens from there to there, just for the first 4 years. After that, the interest rate changes, and it's going to be 16% per annum. 16% per annum. Now it's going to be compounded quarterly. So I put a little 4 in brackets there. Okay. And I want to have 5,000 Rand at the end here. Okay. And so the question is, how much money must I put into the account over here to end up with 5,000 over there? Is this, and I'm going to ask us, guys, I'm going to ask us just to block out this, okay? Okay, so I'm going to ask us just to not think about that for now, okay? All right. Is this an A value or a P value? Well done, it's an A value. Have we got enough information to work out the P value for this last piece? Yes, okay. And if we can do that, then that can be an A value for this piece. Am I right? Okay, so let's just do that together. Right? On this one here, 5,000. Okay, and I haven't written the formula just to save a little bit of time here. I know I should have. 5,000 is P 1 plus 0.16 divided by 4. What power? How many years and how many quarters are there from here to here? How many? Yeah, 2 years, and how many quarters altogether? 8. Well done. Because it's 4 quarters in each year times 2. It's 8. Okay. How many variables are in this equation? 1. Elilodra. So we can work out what this is. We don't even have to work it out. We can just put it straight into our calculator. P will be 5,000. I know that 0.16 divided by 4 is 0.04 to the power of 8. Okay, and I'll get my answer. $3,653 and 45 cents. I'm not going to round that off. I'm going to keep that answer. I'm going to store it. I'm going to go shift store A. 3,653.45. Okay, so 3,653 and 45. Now, guys, look at this here. Do you see that although I called this a p-value, this is actually must be an a value on this calculation? Because what I want to know is what is the original amount that I must put in. Okay, so I'm going to use the red pen. I'm going to do exactly the same calculation here. I'm going to put 3,653.45. All right, and I'm going to put equals P 1 plus, guys, what's 12% divided by 12? How many percent? 12% divided by 12, 1%. 0, 1. You see that, guys, that there is a multiplier. Do you remember when we were doing multipliers? 1,01. That's a multiplier that's going to grow by 1%. And how many times will Messiah apply that multiplier in 4 years monthly? It'll be 4 times 12. It'll be 48. Okay. And so now my final answer here is going to be this. 3,653,45 over 1,01 to the power of 48. When I use my calculator, I'm actually going to go recall A, all right? And then the calculator will use that, so recall A, it will use that with full accuracy, 1,01 to the power of 48. In 226609, only at the end do I round off. So 2266 and 9 cents. Okay. Now guys, I want to show you a really important idea because these can get complicated. All right? So let's look at this next one. And I'm going to show you the best way of doing this next one. There's 2 ways. All right. So let's just look at this question. It says, I deposit some money here, then it earns some interest, then the interest rate changes. I've drawn the number line for us. Okay, so let's just read it. It says, I deposit 5,000 Rand. So there's the deposit. Then 3 years later, I withdraw 3,000 Rand. and it says, how much will I have in 7 years' time, 7 years from now? The interest rate is that, 12% per annum compounded monthly for 2 years, and then it's 16% per annum compounded quarterly for the rest of the time. Okay, now, most teachers will teach you to work along the number line, okay? So method 1 is to work along the number line. Okay? Method 2 is much easier and much better. I'm going to show you why just now. Method 2 and I'm going to show you that we're going to get exactly the same answer. Okay, I'll explain what I mean by method 2. Alright guys, I'm going to just to save some time, I'm actually just going to do this rather than asking you guys to do it. But what I'm going to do, what I can't do is take 5,000 and minus 3,000, because this 5,000 earns some interest. Okay, so what I'm going to do is I'm going to take my 5,000 and I'm going to grow it with 2 years of compound interest. Okay, and so what will that be? It'll be 1 plus 0.12 over 12 to the power of, how many months are there in 2 years? 24. All right. That is how much money I'll have over there. Now, I can't go right to the end now. I've got to go to this point where this 3,000 gets withdrawn. So what happens next? I need to put 1 more year's worth of interest. Okay? So this is like an A value now, but it now becomes a P value for the next calculation. 1 plus 16% divided by 4. How many quarters in 1 year? 4. Okay. That is how much money I have over here. Then what do? I withdraw 3,000 rand, so I must minus 3,000 rand. This now is how much money is in the account there, after I've withdrawn the 3,000 rand. What happens for the next 4 years? 1, 2, 3, 4. What must happen? It must get interest. Okay? I hope I'm not going too fast here, guys. The only formula I'm using is this one. A equals P, 1 plus I to the N. All right. That amount of money, I must now put how many years worth of interest? From here to here? 4 years worth of interest. Okay? And what's my interest rate? 16%, so it's going to be 1 plus 0.16 over 4 to the power of what? How many years? 4 years times by 4? 16. Alright, and guys, that's going to be my final answer. Okay, I'm going to type it all into the calculator because I want to show you something here. Alright, so I'm going to have to just pay attention with the brackets here. 5,000. 1.01, I'm just doing that in my head, okay, to the power of 24. Right? Okay, that's that. Then I'm going to multiply that by 1.04 to the power of 4. That's how much, guys, that's how much I've got in the account there before I take out the 3,000. Take out 3,000. That's how much I've got there. And now, last one I'm going to put on this interest rate. So I'm now going to go times by 1.04 to the power of 16. With 8,291 and 78 cents. 8,291 and 78. Make sure you write that number down, even if you need to go and try and get that answer later at home. Okay. I'm going to show you a different method now. I want us to think of the 5,000 in one account. Okay? And I want us to work out what is that 5,000 worth right at the end. Okay? So it's going to be worth 5,000. It's going to get 1% per month for 24 months. And then it's going to get 5 years of the 16% monthly, so it's 16% quarterly, it's 4%, but it's going to be 5 years. And I can work that out. Right, so all I'm doing, guys, is I'm taking that 5,000 Rand and I'm working out what it's worth right at the end. Okay? And if I do that, I'll show you what it comes to. 1,01 to the power of 24. 0.04 to the power of 4. And I get 7,4 not to the power of 4, to the power of 20. Okay, I get 30,910.72. Okay, I'm going to store that and I'm going to put it into B. Okay, so that number's in B. Now, what I'm going to do is I'm going to work out what this 3,000 Rand, and it's a negative amount, okay, because it's a withdrawal. I'm going to work out what that is worth at the end. Right. So I'm going to take that minus 3,000 and I'm going to put 1, 2, 3, 4 months, 4 years worth of interest. 1,04 to the power of, this is quarterly, so it's to the power of 16. I get negative 5618.94. Right, and I'm going to put that into C. Okay, now guys, what I've done, I've just taken that right to the end and I've taken that right to the end. If I add them up, so I'm just going to add B to C, so I've got B, recall B, plus recall C, I get exactly the same answer as before. Do you see that answer there and that answer there? 8,291 and 78. Okay. Now, you're probably saying, Paul, I prefer the first method. Okay. I'm not going to do this question, but I'm going to just show you. I'm going to show you something here. All right. A man deposits X. 2 years later, he deposits a further X. 1 year after that, he withdraws X. 5 years after his initial deposit, so over here, he's got 10,000 Rand. And the question says, find X, and the interest rate changed here. So the interest rate here was 10% monthly, just for the first year. And then for the rest of the time, the interest rate changed and it was 12% quarterly. Okay. Right, now, I'm going to just, and it doesn't even matter if you don't write this down, even if you just watch what I'm going to do. If I use method 1, okay, I'll show you what's going to happen. We're going to get X with 10% compounded monthly, so it's going to be 1 plus 0,1 over 12 to the 12. That's how much we'll have over there. Then we've got to put on 12% compounded quarterly, so it's going to be 1 plus 0,12 over 4 to the power of 4. That's 1 year of quarterly interest. Then we're going to add an X, okay? That's how much we've now got over there. Then that is going to become a p-value, and we're going to put 1 year's worth of interest on. So it's going to be 1 plus 0,12 over 4 to the 4, right? And then we're going to minus an X. That's going to become a p-value for here, and now we've got 2 years, so it's going to be 1,03, and that's to the power of 2 years would be 8 quarters. All right, and that equals 10,000. And now, guys, now this is where it becomes very complicated, because we've got to try and solve for X. And you see where these X's are they're all stuck inside there, they're all embedded. Okay? Method 2, and I'm not going to answer method 1 because it's almost impossible, but method 2, I'm going to take this X and I'm going to work out what it's worth right at the end. So I'm going to think about that X in one account. Maybe this is with First National Bank, okay? And that's going to be quite easy because it's just going to be 1 year of 10%. And then it's going to have 4 years of this 12% divided by 4, so 3%. But 4 years, quarterly is 16. Okay, that's what that will be worth. Then, the next one is going to be worth, it's just this X here, and it's going to be multiplied by 3 years worth of interest of 1,03. 3 years, quarterly, 12 quarters. Okay? This one over here is a negative X, and it's going to get interest of 1,03, but only for 2 years, and 2 years is 8 quarters, and this equals 10,000 Rand. Okay, I want you to look at those two equations, all right? This is method 2, this is separate accounts. So what we're thinking about here is we're thinking about this here, and that's what it will be worth. This here, and that's what it will be worth. And this here, and that's what it will be worth. Notice this one's negative, okay? Which equation is going to be easier to solve for X? Method 2, so much easier because I can just factor X out, okay? And then I can just divide everything that's left inside through and I can get the answer. Method 1, guys, the equation is almost impossible to solve. So I know that's been quite heavy, this last piece. We're going to leave finance here, but all I'm suggesting to you with timelines, it's often better just to work each amount out separately than to work down the timeline. When you work down the timeline, it can get very messy like this over here. Okay, all right, guys, we're going to take a tea break now. Please be back here by 11:05. Okay, back inside, seated in the same places. Remember, please don't take more than one biscuit, okay? Otherwise, your friends won't get. Once we come back from the tea break, we will start some probability. Okay, thanks. We'll do some probability and then we'll move on to some trig, and then if we've got time at the end, we will finish off with some data handling. Right, guys, there are only two formulas, so there's a little bit of sort of some notes here, but there are two formulas that we get provided. So maybe you just want to make a note of those two. On my screen here, they're the two formulas that are in blue, right? So these two get given. Formula is given. Okay, and to be honest, this first one isn't really all that useful. I think most of us just use it just without even needing the formula, but we'll talk about it just now. Then just a reminder that a probability is always a fraction. It's always between 0 and 1. You can't get an answer bigger than 1, and you can't get a negative answer. Remember that 1 means definite. You might want to use the word guaranteed. Probability of 1 means it's definitely going to happen. And a probability of 0 means it's impossible. Possible, it cannot happen. Okay, we have this idea of what we call the probability of something not happening. Okay, and that's called a complement. And the complement is always just the balance. Okay, so for example, if the probability of rain today is maybe 0,2, that's 20%, then the probability of not rain would be what? What's the probability that it won't rain? 0,8, it would be 80%. Okay, because these two add to 1. Okay, notice here I've used a little dash because a lot of the books don't use the line on the top. I prefer the line on the top because it's easier to see, but some books use a little dash. This means not rain. Okay, not rain. Okay, this is a really important idea, and we will look at it as we do some examples. The complement of at least 1 is none. Okay, and I'll explain what we mean by that when we get to it. Now, there are two big ideas, right, which people really struggle with. The first one is what we call independence, all right? Independence means that the things are unconnected, okay? And you don't get given this formula. It's a pity because it's a useful formula, but what it says, and it says that A and B are, if A and B are independent, okay, then the probability that they both happen is equal to the product of the probabilities that each of them happen. Okay, so I'm going to say it again. If A and B are independent, the probability of A and B is the probability of A times the probability of B. But this arrow, you'll see it goes both ways. It goes left, right, and right, left. If this is true, then A and B are independent. Okay, so I'm going to give you two examples of independent things. Okay, if I throw a dice over here and I draw a card, those are independent things, right? Because the dice is not influenced by the card. They don't have any effect on one another. On the table here, I've got some sweets, okay? There's different colors, okay? If I mix them up and I close my eyes and I take a sweet and I put it back and I mix them up and I take another sweet. Independent. Independent because the sweet that I take the first time will not influence the sweet that I take the next time. Good one. If I mix them up, I close my eyes, I take a sweet and I eat it. None. Okay? Now, I mix them up and I take a sweet. Those are dependent events. Okay? Now they're dependent because the sweet that I ate the first time, the red one, is now going to affect the probability of the next time round. Okay? All right, so independent, they have no effect on each other. Dependent, there's an effect, okay? But this formula here, hey, it's important. So we can test for independence, because if this happens, this has to happen. And if this happens, this happens. The next one that I want to talk to you about is mutually exclusive. When things are mutually exclusive, they cannot both happen. Okay, I'm going to give you an example of mutually exclusive. Finding a learner in this room who is from Amahlubi and also the same learner is from Mnyezaneni. What's the probability of that? 0. So, when events are mutually exclusive, then the probability of them both happening is 0. I'm going to give you an example of non-mutually exclusive. A learner from Mnyezaneni and the learner is in grade 11. There are learners like that in this room. Okay, so that's got a probability that is not equal to 0. So this here, if A and B are mutually exclusive, then we know that the probability of both of them happening is 0. Also, if the probability of both of them happening is 0, then they are mutually exclusive. Now let's look at an example. This first question, and I'm going to ask you to do the second question just now, but let's just look at an example because for me, this example explains all the rules and we can make sense of all of it. This is a Venn diagram. Let's fill it in, okay? We are told that the probability of A and B is 0,3. The probability of A is 0,5. And the probability of B is 0,7. I want someone to help me. Maybe you can just put your hand up, drawing this Venn diagram, okay? What am I going to put where?
So we're going to put 0.5 in the probability of A.
Where? Here?
Yes.
Okay.
And 0.7 on
Yeah.
and 0.3 middle of A.
There. Okay. Nancy Kenya. Okay. We have a problem because if we add these up, we've got more than one. Okay. So something's gone wrong here.
So I made a mistake.
Okay. That's okay. It's fine to make a mistake.
You're going to say 0. You're going to put 0.3.
Well done. We're actually going to start there. Then what are we going to put here?
You're going to say 0.5 minus 0.3.
Hala. Okay, guys. Because the probability of A is everything inside that circle. And now we can see we've got 0,5 in there. Okay, and carry on.
You're going to say 0.7 minus 0.3.
Well done. So the probability of B is 0,4. Sorry, the probability of B is 0,7. The probability of A is 0,5. And the probability of A and B is 0,3. Hala. Just, we're not quite finished because there's one more number. These don't add up to 1. These don't add up to 100% yet. What do they add up to?
They have to 0.9.
Yeah, so what are we missing? How much? Out of the 1. Out of 1 total.
0.
Where am I going to put that? Here. Outside, here. No, here. Okay, cool. All right, great. Thank you very much. Well done. Okay, so that was cool because you made a mistake and then you realized what the mistake was and you fixed it. Now, can someone tell me, just looking at this diagram, are these events A and B, are they mutually exclusive? And I want you to tell me why. Okay. Yes or no, and why? Halala, brilliant answer. Probability of A and B is not equal to 0. Okay, now guys, remember I wrote these two things in the red boxes. I put red boxes around these two very important things. Are A and B independent? Who can tell me? And I want you to tell me yes or no and why. Remember, just give me a reason. Do you remember that song? I've played it to you before. Remember the one, the geometry song? Megan, no, not Megan Trainor. Not Megan Trainor. Pink.
So can you come to the question?
Okay, are they independent? Are A and B independent? But I also want you to tell me why.
So what I would do is say the probability of N is equal to N probability of A times.
Okay, I'm going to ask that you don't put them equal to each other because we don't know if they're equal yet. Okay, so don't do, okay, tell me what these things are. What's this one? What's probability of A and B? What's the answer to that?
Of A and B 0.3.
Okay, well done. And over here?
0.5 times 0.7.
What's that? Do you know? Guys, this is easy. Let me show you how I'm going to work this out in my head. What's 5 times 7? 35. Do you think the answer is 35? No. Do you think the answer is 3,5? No. The answer is 0,35. Okay. You don't need a calculator. Okay. Now, tell me, are they independent?
I'm going to prove that by using the
Okay.
say the probability of N
So are they independent or not?
Yeah, I'm saying what I do.
Yeah.
Question asks event.
Yes. Just listen, guys.
Use the general formula of probability.
Okay. I'm not sure which one you're talking about, but yeah.
This one will say probability of A of B equal to 12.
This one here. Okay. Okay, yeah, but in fact, I know I think I know what you're going to do, but I'm going to ask if someone else can just explain right now why do I know if they're independent or not without using that formula? Because I don't want us to, we don't need to use that formula. Are they independent? Okay, they are not, no, why not? Well done. That's all we need to say. Okay. All right. Guys, the probability of A and B is 0,3 and the probability of them multiplied together is not 0,3. So they're not independent. Okay. All right. Now, this question here and this question here helps us understand the formula because now I'm going to use the formula that you were talking about, my friend from Mnezaneni. Okay. We're going to see why this formula works. If we go for the probability of A or B, the formula says, take the probability of A and add the probability of B. Guys, I'm just looking at this formula over here. Now watch what happens. When I take the probability of A, I'm counting everything inside here, aren't I? Am I right? 0,5. When I take the probability of B, all right, I'm adding everything inside here. What is wrong with that answer at the moment? What mistake have I made? What have I done? If I add everything in the yellow circle and everything in the blue circle, what have I done? I've added this piece twice. Halala. So I must subtract the probability of A and B. Do you see why the formula works? Because if we take the probability of A and we add the probability of B, we're getting that little middle piece twice. Okay, so what's the actual answer for the probability of A or B? It's just going to be 0,5 plus 0,7 minus 0,3. So it's 0,5 plus 0,7 is 1,2, it's 0,9. Okay. Guys, Penduli Kasi, I want you all to try this next question. All right. So it's very similar, but it only asks for the Venn diagram a little bit further down.
Okay, I'm going to ask for an answer for the very first question. Are they independent? Are they independent? Okay, so we've got a hand up there.
No, because probability of A and B is not equal to probability A times probability of B.
Okay, so well done, 100%. They're not, guys. This is 0.25, and that's not equal to the probability of A times the probability of B, because the probability of A times the probability of B is 0.4 times 0.5. It's actually 0.2. Okay, so this number here is not equal to this number here. So they are not independent. Okay, next question. Someone. Are they mutually exclusive, yes or no, and why? Why? Okay, well done. It's 0.25. You might just say it's not 0. Okay, all right. You're 100% correct. It's fine to say it's 0.25. If they were mutually exclusive, that probability would have to be 0. Okay, next up, it asks us to draw a Venn diagram. Guys, I'm not going to do all these questions, okay? I want someone just to tell me what numbers they've got in their Venn diagram, yeah?
We're going to start with 0.25 between A and B.
Over here. Okay.
Okay, put 0.15
Over
A
here.
and 0.25 is probability of B.
Okay. And
it's 0.35.
well done. Hello. Okay. Right. Guys, probability of A or B, we can get an answer from someone, yeah? Anyone? Probability of A or B. You can just give me your final answer here.
The final answer is 0.65.
Hello, well done. Okay, guys, we can do it one of two ways. We can either use the formula, or we can say yes, yes, yes. Those three areas are A or B. Okay, now the only reason I just want to do one of these, guys. Who can tell me what's the probability of A and not B? A and not B. Just put your hand up if you know the answer to that. A and not B. Okay, we're not going to use a formula, we're just going to look at our Venn diagram. Where is A and not B? Well done, guys. A and not B is inside A but not inside B. Who can tell me what about B and not A? Okay, I'll just do it together, 0.25, and then lastly, not A and not B. Yeah, that's right, 0.35, okay. All right, now, guys, tree diagrams, okay? So the thing with tree diagrams, what we're going to do, let's just read this question together. So a bag contains 4 apples, 3 bananas, and 2 pears. Select 2 items, I eat them one after the other, okay? So, guys, banana, sorry, let's go. Sorry, this is a bit confusing because it says apples, bananas, pears. Let's do apples, apple, banana, pear. Okay, and over here we're gonna have exactly the same: apple, banana, pear. To save time, I'm not gonna write the words. I'm just gonna go A, B, P. Apple, banana, pear, apple, banana, pear, apple, banana, pear. Right. I want someone to tell me some of the probabilities here. In other words, I want you to fill these in, and then I'm going to ask Justin to walk around and get some answers. Okay. So remember, there are 4, 3, and 2. Okay, I'm looking for these numbers over here, for these probabilities. First up, if anyone can tell me what those are. So what's the probability that the first piece of fruit I eat is an apple?
The probability of apple is 4 over 9.
Yeah, and banana?
For banana is 3 over 9.
Yeah.
For pear is 2 over 9.
Okay, cool. That's great, guys. If I add those up, I get 9 over 9. I get 1. It makes sense. There's nothing else that can happen. Thank you. Well done. Right, now, and this gets a little bit more interesting, I've eaten an apple. Okay, so now this is a dependent, there's a dependent thing here, but we're not going to use any formulas. We're just going to count. Okay, I want someone to tell me these 3 probabilities. The probabilities of these bits of fruit if I ate an apple first. Okay, so we've got a hand right at the back, or yeah, there might be one closer. There's one right at the back. You might find one on your way to the back, Justin. Justin's also trying to give different people turns, so he might not come to you because maybe you've answered lots of questions already. Maybe not.
Apples we're gonna have, it's gonna be 4 over 4.
Okay, there's a few people in the room who are unhappy with 4 over 4. How many bits of fruit are left if I ate one? How many bits of fruit? There were 9, huh? So how many bits of fruit are left now? 3 over 8. Okay, just now it was 4 over 4. It's changed. Okay, all right. And for banana? Yeah, because I ate one apple, so the bananas are still there. And then this must be what? Yeah. And guys, what do these add up to? If I add these fractions, they add to 8 out of 8. 1. Hala. Okay. Right. I want someone to give me the next ones over here. Apple, banana, pear. If I eat a banana first,
The apple is 4 over 8.
well done. Because there's still 4 apples, yeah?
2 over 8.
And? Well done. And?
2 over 8.
Hala. Okay. Last one. If I eat a pear first, what's the probability of getting an apple, a banana, and a pear for the second piece of fruit?
Apple going to have 4 over 8.
Yeah.
Then we'll have for bananas we have 2 over 8.
Yeah.
And then for pears we have 8.
Well, okay. And guys, those add to 8 over 8. Now, what we can do, we multiply down the branch. Okay. So if we multiply this by this, we get 12 out of 72. That is the probability of having 2 apples. The probability of having an apple, then a banana, if I multiply, I get 12 over 72 as well. The probability of having an apple and then a pear, 8 out of 72. 12 out of 72. 6 out of 72. 6 out of 72. 8 out of 72. 6 out of 72. And 2 out of 72. Right, now I want to show you, if we add these up, guys, 12 plus 12, 24, 32, 46, 52, 58, 66, no, stuff that up. 12 plus 12, 24, 32, 44, 50, 56, 64, 70, 72. If we add them all up, we get 72 out of 72. What's 72 out of 72? It's 1. Does it make sense? It always makes sense. Okay. What is the probability that I have both the pieces of fruit are pairs? There it is there, guys. 2 over 72. What's the probability that I have exactly one banana? Now, just be careful because I can have one banana. Here on this branch, I have one banana. But that's not the only place where I can have exactly one banana. I could have a banana here, and then where must I go now? Either apple, right? Either apple or a banana and a pear. And what's the last way I can have exactly one banana? To have a pear first and then have a banana. Now guys, I need to count all 4 of those branches. So I'm going to put little ticks next to them because you probably haven't got the highlighter. There, and there. So my final answer, I'm just going to make it a little bit smaller so I can see. My final answer is going to be 12 over 72, that's that one, plus another 12 over 72, that's that one, plus a 6 over 72, plus another 6 over 72. Okay, and if I add all these up, I get 24, 30, I get 36 over 72. 36 over 72 is exactly half. It's exactly 50%. Okay. Now, the probability of at least one apple. All right. Now, where okay, this is not yeah, this doesn't really help us to use a shortcut here, but anyway, it doesn't matter. Okay. All right, guys, which branches must I count? Let's just go from the top. And I'm going to tick them if they've got at least one apple. This one, must I tick? At least one apple. Guys, at least one apple means either one apple or 2 apples. I must definitely tick this one. What about this one? Yes. On this branch, do I have at least one apple? Yes. On this branch? Yes. Guys, there's the apple there. On this branch? No. This branch? No. This branch? Yes. This branch? No. And this branch? No. Okay. So there's basically what we're going to just add them up, I think. So we're going to get 12 plus 12 plus 8. I'll write them down. Yeah, so 12 plus 12 plus 8 plus 12 plus 8. 12 plus 12 plus 8 plus 12 plus 8. All right, and I've got 36, 44, 52 out of 72. Okay, pendule ikasi. All right. Okay, guys, now, this spinner is spun, so we spin it and we see what color it lands on, and this coin is tossed. And they ask for what is the probability of heads and red? Okay, so heads on the coin and red on the spinner. Now, are these things independent? I want you to think about not using any formulas. Is spinning the spinner independent of the coin? In other words, is there any influence on the spinner on the coin? In other words, if I spin the spinner and it comes up orange, is that going to affect the coin? No. These are independent, guys. All right. So right at the top here, and we're not using any rules, we're just using our understanding that this is not there's going to be no influence of this on this. These things are independent of one another. They're not connected. So what's the formula, if we know they're independent, what's the formula for working out the heads and red? What do we do? I'll go back and I'll remind you. If they're independent, then the probability of both, we just multiply the probabilities. So this is going to just be probability of heads multiplied by the probability of red. Okay, guys, what's the probability of heads when you toss a coin? 1 over 2. And what's the probability of red when you spin the spinner? 1 out of 5. Final answer? 1 over 10. Okay. Then, yellow or tails. Now, we can use our formula. Does anyone remember what the formula says? Probability of yellow plus probability of tails minus the probability of yellow and tails. Guys, I'm using this symbol. I hope you're okay with the symbol for and. Okay. So what's the probability of yellow? One over 5. Probability of tails? 1 over 2. And the probability of yellow and tails, I'm going to multiply 1 over 2 by 1 over 5 because they are independent. Remember BODMAS, order of operations? So we've got to work out this one, and then minus this. This, we can do this without a calculator, guys. Let's change this to tenths. How many tenths is this? 2. Okay. 1/5, guys. If I want to make it into tenths, I'm going to double and double. 2 tenths. How many tenths is this? 5. 2 tenths plus 5 tenths? 7 tenths. Minus 1 tenth. 6 tenths. Or 60%. Okay. 6 tenths, 60 out of 100. Okay, now I'm going to do a simpler example here for you. All right? I want you to write this down. Okay, so I'm tossing a coin 3 times, okay, and I'm going to write down the sample space, all the things that can happen when I toss a coin 3 times. Okay, let's see if we can. I could get tails, then tails, then tails. I could get tails, then heads. Okay, I could get tails, then heads, then tails. I could get tails, then heads, then heads. All right. I could get heads, then tails, then tails. I could get heads, then tails, then heads. I could get heads, tails. And lastly, I could get heads, and heads. Okay. Guys, I promise you there are no other options. If you think I've missed one, tell me, okay, but I promise you they're not. Okay. All right, there's only 8 things that can happen when you toss a coin 3 times. When you get to grade 12, we actually learn how to calculate that, but we won't worry about that for now, okay? Now, in which of these throws do I get at least one tail? On this, of the 8, must I count this one? Yes. And this one? At least one tail. Yes. And this one? 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 Yes. Okay. Now, the only one I'm not going to count is that one. Okay. So I want you to write this down. The probability of at least one is going to be 1 minus the probability of none. Okay, so it's going to be 1 minus, the probability of getting heads is 1/8. So the final answer is actually 7 out of 8. But that 7 out of 8 I can calculate in one of two ways. I can either say 1, 2, 3, 4, 5, 6, 7, or I can say 1 minus the probability of none. Okay, right, now we're going to look at actually question 5 as it was asked. So the spinner in the question 2 is spun 15 times. What's the probability that I get yellow at least once? Now, to write down the options for the spinner, if you spin it 15 times and there are 5 different options each time, it's a huge number. We can't write it down. But what I'm going to write here is I'm going to write probability of at least one yellow that's going to be 1 minus the probability of no yellows. Okay. When I spin that thing for the first time, so you've got that spinner on your page, there it is there. What's the probability that I don't get a yellow? 4 out of 5. Okay. When I spin it for the second time, I want to get another non-yellow. Another 4 out of 5. And another 4 out of 5. Okay. 15 times. So that will be a non-yellow, 15 non-yellows. And what I do is I go 1 minus the probability of that. So my answer is actually going to be 1 minus 4 over 5 to the power of 15. Do you see what's happening here? Every throw is independent, and because every spin rather is independent, and because they're independent, I can multiply the probability. So I want a non-yellow, 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 non-yellow. Right. Every other instance will have at least one yellow in it. Okay, now let's get this answer. I think it's going to be quite close to 1. You think about it, if you spun that spinner 15 times, you would expect to get yellow. At least once. Okay, let's see what it is. It's 1 minus, let's put a bracket here, 4 over 5 to the power of 15. Okay, it's 96,48 or 96,5%. All right, and if you spun it, I'm just going to, sorry. If you spun it 20 times, I'll just show you. If you spun it 20 times, it goes to 98%. If you spin it 30 times, it's going to go to like 99, you see, 99.9%. Okay. All right. You'll remember that I highlighted right up at the top here, I said the probability of at least one, okay, goodness, something's gone. My computer's. Sorry, guys. The complement of at least one is none. Okay, so the probability of at least one is 1 minus the probability of none. Okay, I want to skip some questions now. I want us to look at this question over here. Okay, so just find this question. It'll be easy to find because there's a Coca-Cola logo here. Okay, this table, all right, This table is called a two-way contingency table. So there's two things. We talk to a whole lot of people and we ask them whether they like Coca-Cola or they don't drink Coca-Cola. And some of the people we talk to are male and some are female, and we collect all our results. Now, the first thing is I want you to fill in the rest of this table, okay? And then I want us to work out, is liking Coke, is that independent of gender or is it dependent of gender? Okay, in other words, let's just have a look. Okay, who can tell us how we're going to fill in this table? What numbers are we missing? Where can I start? Yeah, so we've got some answers here. There's an answer right here in the front row. Okay, there was one just further. Yeah, carry on. So, thank you.
For me, 27, don't drink Coke.
27, yeah. Okay.
But don't drink Coke, women is about
30.
But don't drink Coke, women is about 18.
18.
The missing is about 48.
Okay. All right. So these two add to 120. Yeah, that's looking good. Yeah. 75. Allah. Okay, well done. Right. Okay, now, guys, remember how I test for independence. We'll just use A and B for now. Remember that if these things are independent, then the probability of A and B will be equal to the probability of A times the probability of B. Remember that? Okay. So now we're going to use that same idea to test whether your gender, whether you're male or female, is independent of drinking Coke or not. So we choose any one we like. Let's say the probability of male and Coke. So a male that likes Coke. Guys, of these 120 people, if I choose someone at random, what's the probability that I choose a male who likes Coke? How many males are there who like Coke? 45 out of? Not out of 75. 45 out of 120. Okay, let's put that in our calculator. 45 out of 120. 0.375, huh? Yeah. Right, now, I'm going to do exactly this, guys. I'm going to work out the probability of male multiplied by the probability of drinking Coke. Right. How many males are there altogether? 75 out of 120 people. What's the probability that I pick someone who drinks Coke? 72 out of 120. Okay, let's work this one out. So this is 75 out of 120 times by 72 out of 120. And I get 0.375. Are they independent or not? They are independent. Okay. Guys, what that means, it means that it doesn't matter whether I choose a male or a female, the chances that they like Coke will be the same. Okay. There's no relationship between gender and liking Coke. I'm going to ask you guys a different question, okay? And maybe the boys in the room won't even know. But there's a TV program called The Wedding Planner. Okay? And in the wedding, I heard some girls say yes. Okay. In The Wedding Planner, They discuss like the choices for a wedding, like what food shall we have, what dresses, what dress should the bride wear, the bridesmaids, what dresses should they wear, what color serviettes on the table must we have. Okay, so if we had a table here where we said they watch the wedding planner and they don't watch the wedding planner, and we had boys and we had girls, okay? Do you think these would be dependent or independent? These would be deep. I think this would be dependent. And what we're saying there is that if you're a girl, you're probably more likely to watch the wedding planner than if you're a boy. Okay, that's my gut feel. Okay, but obviously when you're answering the questions, you just work with the numbers that you get given. Okay, let's do one. Yeah, let's do this question. Question 10. This would be our last probability question. In fact, guys, try question 9 and question 10. Okay, let's do both. We'll do both of those. I can ask Justin to come and find if we get an answer. Okay, anyone got an answer for either of them? You can tell me which question you're going to answer when Justin gets you. It doesn't matter. I'll do 10 first or 9 first. It doesn't matter. Yeah, let's have someone else putting up your hand. Okay, we're getting the same people. All right. But Justin, the same thing happens in our class. And the same people put their hands up. Okay, right. Which one are we doing, 9 or 10? 10, okay. Well done. Guys, this is just 0, all right? Because they're mutually exclusive, right? So unfortunately, lots of people will multiply those two answers together, but it's not right. They're mutually exclusive. So as soon as they're mutually exclusive, 0, okay? Probability of A or B? Okay, all we're going to do, you're right, you're 100% correct, 0, come down to, we're going to do this. We're going to use our formula, but this piece is 0, so it's just going to be 0.35 plus 0.57 minus 0, so it's 0.92. Well done. All right, 92%. Okay. Let's have a look at question 9. Question 9, anyone? So we told that, and we asked to find A or B. What are we're missing something here? Yeah, so... Yeah, let's go with this Mnyezane Niluna right here.
A and B, probability A and B.
Yeah, so...
Probability A and B is equal to probability A and B.
Yeah, is equal to?
Probability A.
Okay, cool, correct. And guys, the reason we know that is because they're independent. Okay, right. So now what can we do? Yeah.
Yes.
Yeah, we don't know that yet. Okay. Well done. Okay. So Well done. Both sides, I like that. We get 0.2. Now we know probability of A. Okay, and now what are we going to do? Yeah. 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 Well done. Okay, and so it's going to be 0.2. Okay, that's 0.8, 0.68. Well done. Okay, right, guys, we're going to leave probability. I think it's a nice topic. I like probability. Okay, don't be scared of it. We're going to go now, all right, and we're going to start looking at some trigonometry. Okay. Okay, so find this page, guys. All right, and I'm going to show you, we're just going to do one example, but just because I think it's a very cool example, we're going to do one example using trig ratios. You do not get told these in the formula. There's no formula sheet for this. So you need to know that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. Guys, the hypotenuse is always opposite the right angle. The opposite is opposite the angle, and the adjacent is next to the angle. Now you might say, Paul, this one's next to you as well. It's got a name already though. If this is the angle, this will be the opposite, and this will be the adjacent. Okay, so it does depend which angle you choose. The hypotenuse is always the hypotenuse. Okay, right, now, apart from that, we also know Pythagoras. We also know that the angles of a triangle add up to 180 degrees. And then the last thing that maybe you don't know, but I hope you do know, is that when you draw a triangle, the biggest side is always opposite the biggest angle. The smallest side is always opposite the smallest angle. Okay, and that, I don't have a name for that, so I call it the SEMI test. Okay, Shaisi Bible Maths Institute test. All right, but we'll check that just now. There's this idea of angle of inclination. It's how much you're looking up at something, and angle of innovation, angle of depression, how much you're looking down at something. Now, I want to show you this thing, okay? I made this thing. It's very, very simple. It's just got some angles measured on here. It's got a tube from a pen, okay? It's got a piece of string, and then it's got a weight. Now, in order that the learners that have joined us online can see, I'm going to show you a very short video. This video was made during COVID, okay? So I hadn't been anywhere near a hairdresser or barber, so you'll see my hair is quite long in this video. Okay. Okay, just have a look here. I'm just going to mute that. All right. So there's the thing that I've just held up, okay? It's got a piece of string, and you can see it's got angles. It's got like a protractor on there, all right? So it hangs down like that. And if it's horizontal, it reads off at naught, okay? Now, what I'm going to do is I'm going to look up at the top of something. I actually looked up at the top of the rugby pole, okay? Through the pen, I look there, through the middle, it's like a little sight, and then at the moment it's at 0, because I'm not looking upwards at all. But if I look up now at the top of the rugby pole, okay, through there, then I can see what angle I'm looking up at. Okay, so that's an angle of inclination. Very, very simple thing to get. Now, what I'm going to show you, for me this is very, very clever. we can work out the height of something just using that little tool. So I'm going to do this, okay? Let's look at this question here now. Here's a big tree, okay? And we don't know how high the tree is. We want to know how high the tree is. But maybe there's a house over here. So I can't even get to the tree. The tree's over there, it's far away. Okay. All I do is I take that machine, okay, and I measure how high what's the angle of inclination to the top of the tree? And it's 50 degrees. Then I walk on flat ground 5 meters closer. Okay? And I take another reading. Now, I'm hoping you realize that as you get closer, let's have a look at that speaker there. As I get closer, I need to look up more and more. Do you agree? When I get closer, the angle of inclination is going to get bigger. Okay. All right. With that information, I can work out the height of the tree. I've got enough information. Okay, and I'm going to show you how we're going to do it. All right? I'm going to call this distance here D. Okay? And I'm going to call this height here H. Is everyone okay? Which trig ratio would involve that and that? The opposite and the adjacent. Guys? Is everyone okay? The tan of 60 would be H over D. Okay? And if I multiplied both sides by D, I get H is actually D times tan 60. Okay, that's in Kinga because there's 2 variables. What do we do in maths when we've got 2 variables? Well done, simultaneous equations. Because, guys, in this big triangle, okay, notice I didn't put the right angle, but there's a right angle in there, okay? In the big triangle, if I use the 50-degree angle, what's the opposite? It's still H. But what's the adjacent now? What's this total side here? 5 plus D. Okay. And if I multiply by 5 plus D, I get H again. All right. Now I've got 2 expressions for H. And I want to solve. Okay. So I'm just going to put them equal to each other. D tan 60 is 5 plus D tan 50. Okay. I want to get D. All right. Now this is like grade 9 equations maybe. I want to get D. It's here and it's here. What could I do on the right hand side? I could get rid of the brackets. Am I right? So I would get D tan 60 is 5 tan 50 plus D tan 50. Can anyone suggest what I'm going to do next? I want D. I'm trying to get D. What would be a good thing to do next? If I want D, surely I want all my D's on one side. Yes? Should I subtract D tan 50 from both sides? If I subtract D tan 50 from both sides, I'm left with D tan 60 minus D tan 50 is 5 tan 50. Okay, now here's the question. All right? I want D, and D's over here, and it's also over here. What mathematical technique can I use to get those D's into one place? Say it loudly if you know it. Well done, factorize it. If I take out a D, what will I be left inside? Tan 60 minus tan 50. And that equals 5 tan 50. Okay? Because all right, and now, guys, what must I do to both sides to get D? Divide by all that stuff, so I get 5 tan 50 over tan 60 minus tan 50. Okay, and can someone tell me what do I get for D? If you put all that into a calculator. 11? Okay, keep whatever it is, 11 meters or whatever, keep that in your calculator, because I want H, and H is just going to be that number, D times tan 60. So just on your calculator screen, just go times tan 60. And we get I think it's 19 or so. Okay, I'll just quickly do it here. 5 tan 50 over tan 60, 60 close brackets minus tan 50 close brackets. Okay, so that's the answer for D. Then I'm going to multiply that by tan 60. So I'm going to go times tan 60. So I'm just putting it back into the top equation. And I get 19,1 meters. Now guys, I don't know about you, but I think that's very clever. All right? Because we didn't get to the tree. The tree was over there. And even a mountain that's far away, as long as you are on the same horizontal plane, you just take 2 readings and you can get the height. Okay, now, in grade 10, last week the grade 10s were here. In grade 10, we only deal with right-angled triangles. In grade 11 and 12, we deal with non-right-angled triangles. So there's 3 new rules here. And if you look at on the test content here, it actually says proof and application of those rules. So I'm going to quickly prove these rules for you, and I want you to just write them down as I do them. Okay? The first one is the area rule. Okay? We are going to prove that the area of, and guys, I'm purposefully going to use different letters here. I'm going to use the triangle EFG. And I'm going to prove that it's half E times F times the sine of G. Okay. So what I'm going to do, if that's what they ask you to do, you draw this triangle, but you put the angle that you're trying to use, you put the angle there. So that's G, and that's E, and that's F. It doesn't matter where you put E and F, you must put this angle at the origin. Okay? So there it is, and there it is. Now, what we're going to do, remember, area is half base times height. The base, guys, is just going to be this side of this triangle. That's going to be E. Do you agree? That if that's big E, this is little e. Okay, so it's going to be half times E. Now, what we need now is we need the height. Okay, and I'm going to show you how we can get the height by drawing in a little right angle here. Okay, this side over here is called little f. It's opposite big F. Who can tell me which trig ratio is going to involve this angle and the opposite and the hypotenuse? Yeah. Do you agree that the sine of G would be the height over F? Am I right? So what will the height be? It will be F times sine of G. Okay, now if I put the height in here, I've done it. Do you see that I've proved the rule? Okay, so what you're going to do, draw your triangle in, but put the angle in the right place. Label the opposite sides of the triangle, okay, so the F and the E. This here is little g, we don't actually need little g, all right? And then draw in the height and work out an expression for the height, and then just use half base times height. Okay, that's the proof of the area rule. Right, now, the next rule that we're going to look at is the sine rule, okay? And if we've got a triangle, this time I've used triangle ABC, all right? If we put angle C on the origin, we get half AB sine C. If we put angle B at the origin, we get half AC sine B. And if we put angle A at the origin, we get half BC sine A. Now, that's the area of the triangle. But when you turn the triangle around, it doesn't change size. It doesn't get bigger or smaller. So all of these areas are actually equal. All right? So if they ask you to prove the sine rule, you first need to prove that the area rule, and then you can write down these other two versions of the area. And now, in this equation, if you divide everything by half, and by A, and by B, and by C, you get your sine rule, okay? And the sine rule can be turned upside down as well. All right, so that's the sine rule. I want to just quickly show you a sketch for the sine rule. Okay, there it is over there. Have a look. If I take the blue side divided by the sine of the angle opposite it, I get exactly the same as if I take the green side divided by the sine of the green angle. And I get the same again if I take the red side divided by the sine of the red angle. Watch as I drag this round. All the angles and all the sides are changing, but these numbers here are all the same. Do you see the semi rule, guys? Which is the biggest side now, the green, the red, or the blue? The green. Which is the biggest angle? The green, the red, or the blue? The green, guys. They've got to be. Which is the smallest angle? The blue. The smallest side is the 6, is the blue, and the blue. Okay, doesn't matter how you drag a triangle, all right? The biggest side now is the blue side. It's opposite the biggest angle. The smallest side is opposite the smallest angle, and the middle sized side is opposite the middle sized angle. Okay, that's our sine rule. Now, the last one is the cos rule. Okay, and just like for the area rule, suppose I want to prove, guys, I'm going to do another one. I want you to prove that m squared is n squared plus p squared minus 2 times n times p times the cos of, let's say, q. Okay, so all we do, no, it won't be the cos of q. It'll be the cos of m, sorry, guys. Right, you know from your cos rule, this one's opposite that one, okay? You draw your triangle, put this angle over here. Doesn't matter where you put your other two angles, so I'm going to call this one N, and this one P. What's this side here called? It's little m, and this is little, and this is little n. Okay, right. Now, what I'm going to do, exactly like I did before, I'm going to work out the coordinates of this point. Okay? And the way I'm going to do that, exactly as with the sine rule, I'm going to draw in a little triangle here. Okay? But now this time, I'm going to call this y, and I'm going to call this x. All right. Which trig ratio, this is a right angle triangle, Which trig ratio involves my angle M and Y and P? Sine. Well done. So the sine of angle M is Y over P, isn't it? What's the cos of angle M? Guys, how do we work out cos? It'll be X over P. Multiplying both sides of both by P, I get Y is P times sine M. And here I get X is P times cos M. Okay, and so here they are. I can write them in here. P cos M, P sine M. You can learn these, all right? I'm not a big fan of learning stuff that I can work out. Okay, now, what's the coordinates of this point over here? It's on the x-axis, so its y value must be 0. And this distance is n, so that's n. Right. Now the last thing I'm going to do is I'm going to use my distance formula from analytical geometry to work out the distance of m. Okay? But instead of going m with the square root, I'm going to go m squared. Okay, and how does your distance formula work? You remember you take your x's and subtract them. So I'm going to get p cos m minus n. That's the two x values subtracted and squared, plus the two y values subtracted and squared. So p sine m minus 0, and I'm going to square, and I'm going to square. Okay, now, this one, don't forget how to square properly a binomial. We've got to square this, so we get p squared cos squared m. Then I'm going to get this times this doubled. Remember my 2ab, okay, my outers and my inners. So I get 2np cos m, and I get plus n squared. Okay, so that's the expansion of that first bracket. This one, the minus 0 just goes away, so it's just p squared sine squared m. P squared sine squared m. All right, now, look at, this is looking good. This here is exactly what I want. This here is exactly what I want. But I want both of these two terms to just be p squared. Who can tell me, how do I get from here to the cos rule? So I've got n squared. I've got p squared. Who can tell me, how am I going to get p squared cos squared m plus p squared sine squared m just to be p squared? Well done. Take it out as a factor. So I'm going to get sine squared m plus cos squared m. What's sine squared m plus cos squared m? It's 1. Well done. Okay? Minus 2np cos m. All right, and guys, there's the final answer. N squared plus p squared minus 2np cos m. All right, and guys, that's the proof of the cos rule. I don't think it's difficult. I wouldn't try and learn it off by heart. I would remember the first thing is that you must put the angle must go at the origin. Then you work out the coordinates of these points, okay, using trig ratios, and then you use your distance formula. And lastly, you've got to remember to factor out the p squared to get your identity. Okay, right, now, we're now going to look at a couple of questions, okay? And in a lot of these questions, you will see an ibu locho, a bridge, okay? Let's look at the first question and I'll explain why there's a picture of a bridge. Okay, this question asks us, I'm going to go straight to part B. It asks us to calculate the height of the tower. All right, now in this triangle over here, this red triangle, I do not have enough information. I've only got the right angle and a 50-degree angle. I haven't got any lengths. But I can work out this length here, okay, using, what rule can I use to get this length over here? Yeah, I can work out the sine rule. What I'll first need to do is say that this is, maybe you might not need to work this out. I'm not going to work this out. What do I know about an exterior angle of a triangle and the other two? The exterior angle is equal to the other two added together. So if that's 13,9, this must be 36,1. Because 36,1 plus 13,9 gives me 50. Okay, I know most of you won't do it like that. You'll work this one out, and then you will subtract. Okay, doesn't matter. All right. Who can tell me, and I'm going to ask Justin to come to you, who can tell me how I'm going to get PM? Okay, let's have someone who hasn't answered a question today, because as Justin said to me just now, it's the same people. Guys, so look in this triangle. It's not a right angled triangle. I'm talking about this green stripy triangle. It's not right angled. So I cannot use opposite, hypotenuse, and adjacent. So my only choices are the sine rule, nor the cosine rule. Okay, let's have someone who hasn't answered a question. There's that any learner the back's answered lots of questions. Also answered lots of questions. Come guys, you need to try. There we go. I know you're probably saying, Paul, we're tired now, eh? Yeah, I'm also tired. Okay? Yeah, okay, let's have a look. I'm trying to find, yeah. Yeah, okay, cool. I'm trying to find PM. So if I go PM over what? Okay, sine of P is 30. Okay, so guys, I'll tell you what I do. Remember the sine rule can go either way up, eh? So I like to put the thing that I'm trying to find on the top. Okay? So if I go PM over sine of what? Which angle? Yes. So sine of 36,1. Halala. Carry on. That will be the same as what?
43,5.
Over
sine 13,9.
Halala. Okay. Now guys, what we've got now, how many variables are left here? Ellie? Lord, what? Just one. What must I do next to find the answer here? What must I do? Multiply. Yeah, I'm not going to cross multiply. I just want to get rid of dividing by sine 36,1. So I'm going to just multiply by 36,1. So this is going to be 43,5 times sine 36,1 over sine 13,9. Are we okay? Okay, well done. You've used the sine rule correctly. And guys, this comes to 106,7. The question tells us, okay, this here, guys, this side is Ipulogo. It's a bridge. That side has got us now into the next triangle. Who can now tell me which trig ratio must I use? I'm now in a right angled triangle. Which trig ratio must I use if I know that side, I know this angle, and I want to work out this side? Who can tell me what? Put your hand up so Justin can come to you. Which trig ratio am I going to use? Over here? Over there? Sine, tell me what it's going to be. Sine of? Sine of 50 is what? Okay. Okay, Pn over Pm, so over 106,7. Okay, guys, because Pm is 106,7 from here. And even if you couldn't do this question, you can still do the second part. What must I do to both sides now to get Pn? Guys, I must multiply both sides by 106,7. Can someone do that for me? Sorry guys, I'm struggling to hear my 106,7 times sine of 50. 81,7, yeah. 81,74, you want 2 decimal places, yeah. And guys, that will be, it didn't actually say, yeah, it did say meters, so it will be meters. Right, now, what we're going to look at now, okay, is, let's just look at this question here, number 2. And I want you all to try it. It says, find the smallest angle in a triangle with sides of 4, 5, and 6. All right. Which rule am I going to use? Well done. I'm going to use the cos rule. You cannot use the sine rule if you haven't got any angles. Okay. Which angle, guys, and I want you to think about the semi test, because I don't need to find all the angles. Which angle must I find if the triangle is drawn like this? Angle C. Guys, angle C will be the smallest angle because it's opposite the smallest side. Okay, now let's use the cos rule, and remember what the cos rule says. It says if we take a side squared, it's the other two sides squared and added together minus twice the product of those two sides times by the cos of the angle opposite the side that we squared. Okay, notice it's actually useful to learn it in words, because if you learn it in words, then it doesn't matter whether what the triangle is called. It can be ABC, it can be DEF, it can be anything. Okay. All right, how many variables are in here? Just one. Just the cos of angle C, or angle C, but we can find the cos of angle C first. Now, I'm going to show you that if you rearrange this, you actually get 5 squared plus 6 squared minus 4 squared over 2 lots of 5 times 6. Okay, and I like to learn this rearranged version. Okay, so what it says is that the cos of an angle are the two sides that make the angle squared and added together minus the one opposite squared over twice the product of the two sides that make the angle. Right, guys, this comes to 25, 36, 61 minus 16, 45 over 60. 45 over 60 is exactly 3/4. Okay, am I right? Okay, some of you have used your calculator and you've checked, but I didn't need to use a calculator. I'm not cleverer than you guys, I promise you. I'm not cleverer than you guys. I use my brain, and so it's become better. You guys have got good brains as well. So now I'm going to go shift cos of 0,75, and we get 41,4 degrees. I wanted 2 decimal places just now. 41,4, 1 degrees. 41,41 degrees. Right, guys, I want to show you something about the cos rule that might not ever have occurred to you, and it might not have occurred to the teachers in the room either. Right, because I was only, someone showed me this a long time ago, but when I saw it, I hadn't seen it before. Look at the cos rule. Do you agree that this piece here looks like Pythagoras? A squared equals B squared plus C squared. Now this stuff here that I've put a line on the top of, all right? So what I'm going to do, I'm going to make the angle A bigger and bigger and bigger. What happens when angle A is 90 degrees? What is the cos of 90? Do you guys know? Guys, watch what's happening to this number over here. This stuff that's got the line over the top of it works out to 4,65. But when the angle is 88 degrees, it only works out to 3,1. When the angle is 89 degrees, it only works out to 1,55. And when the angle is 90 degrees, it works out to 0. So in other words, when it's 90 degrees, cos of 90 is 0, and it's the cos rule. It's Pythagoras, okay. When it's a bit less than 90 degrees, this piece at the back is like an adjustment for it not being 90 degrees. If it goes bigger than 90 degrees, guys, the cos of an obtuse angle like 95, let's just go to like 90, let's go to say 95 degrees or something. This number at the back here now, guys, the cos of 98 is actually a negative number. All right? And so we actually subtract a negative bit. In other words, we actually add a bit. Because do you see that this is longer now? This green side is longer. As the angle gets bigger, the green side gets longer and longer and longer. Okay, so the cos rule is like Pythagoras, but souped up on steroids. Okay, all right, don't take steroids, but that's the cos rule is connected into Pythagoras in a very obvious way. All right, I want you all to try question 3. Okay, and what is this little picture? Ibulocho. Okay, because question 3, you cannot find PQ straight away. All right. And I think it's quite obvious in this question which one, where the Ibulocho is, but have a look at it. Okay, I'm just taking a couple. Right. Okay, I'm hoping someone's got an answer for us for this question. And I would like you to tell us how you did it. Not just your answer, but what did you do? I'm also hoping it's someone we haven't heard from yet. In the middle, there's someone we haven't heard from yet. Okay, hold it nice and close to you. Yeah. Yeah, this one here, yeah. Yeah. Well done. Okay, it's very nice if you can do that directly, which you have. Guys, if you weren't sure how that was done, you can do it in 2 steps. You can multiply both sides by QD. So you get QD times sine of 27 is 40, and then divide both sides by sine 27. Hala, carry on. Okay. Yeah, what did you get? 88,11. Okay. Cos rule, okay, so what did you get? Okay, just to save time, I'm not going to write that step down. So what would PQ, okay, what would D squared be? No, just put the numbers into the cos rule for me. Yes. Yeah. Yeah. Well done, okay. What did you get for your final answer? It's 116, sorry, yeah. Well done, okay. Very, very good. Right. Guys, do you see Ibulocho? Do you see the bridge that we've got to use? And guys, the bridge is very, very common. Huh? Now, I want us to look at, and guys, we're not going to have time to do all these questions today, but you'll see here, Ibulocho again, all right? Okay. So, I'm just checking something here, sorry. So, okay, guys, in your syllabus here, you have to be able to solve questions in 2 dimensions. With my class this year, I think, we've done 3 dimensions, yeah. Okay, but so it's only 2 dimensions. I was looking for a 3-dimensional one. I want us to look at this question here. Question number 5. Okay? Because a lot of people now, they get scared when they see this. All right? They shouldn't get scared, but they get scared because we've got variables everywhere here now. Okay? It asks us to find TC, this length over here. Now, in this triangle over here, this right-hand triangle, this red stripy triangle, we don't have enough information. Can anyone see which side is Ibulocho? Which side is Ibulocho? Which one is in both triangles? TB, well done. Guys, I think this bridge in this triangle is this side over here. So the first thing we're going to try and do, we're going to try and find TB, right? Can anybody tell me what size is this angle here if this is y and that's x? What size will this angle be? I want you to think about exterior angles of triangles, guys. Do you see? Everything's connected. This is y minus x. Now, guys, when I see y minus x, I don't get scared. I get happy. Because look here, there's a y minus x in there. Okay. So let's get Iboloco, let's get the bridge in this right-hand triangle using which rule? Guys, look, does this look like the cos rule or the sine rule has been used here? Sine rule, for sure. Okay. TB over the sine of what? TB over the sine of x. Now, I want to use a length that I know, and I know this length. So it'll be d over the sine of y minus x. So TB will actually be, if I multiply both sides by sine x, TB will be d sine x over sine of y minus x. Now I'm going to go to the other triangle. I've used the bridge. The bridge gets you across a river. A bridge gets you from one triangle to the next triangle. Which trig ratio will involve this angle, this side, and this side? Sine, well done. The opposite and the hypotenuse. So sine of y will be the opposite, TC, over the hypotenuse. Okay, the hypotenuse is TB. So in fact, TC, if I multiply both sides by TB, I just get TB times the sine of y. And now, I'm going to put in what TB is. It's actually d sine x over sine y minus x. And the last thing I've got to do is multiply by sine y. And when I look at this, that is exactly what I was asked to show. Okay. Does it make sense, guys? There's lots that I haven't done. I've left some out. You need to go and try those ones. Okay. The last thing I want to talk to you about today, guys, before we stop, is just some trig graphs. All right. Maybe if you go to your last, go to the back cover, guys. So go to the back page, page 32. I want us just to quickly remind ourselves of some things here. Okay? And again, I think often teachers don't necessarily, haven't thought about this link. Okay? You know this? Okay? This is going to help us draw our graphs, because if I draw a sine graph, it's positive in the first quadrant up to 90 degrees. It's still positive in the second quadrant up to 180 degrees. And then it's negative in the next two quadrants. Okay, so do you see how this thing helps us draw this thing? Positive, positive, negative, negative. Okay, all right. What do we know about the maximum value of a sine graph is? 1, and the minimum value? -1. The period is 360 degrees. It takes 360 degrees to do a full cycle. Let's draw a cos graph. Very, very similar, but it's positive in quadrant 1. Then it's negative in quadrant 2. It's still negative in quadrant 3. And then it's positive in quadrant 4. Okay, so there's a cos graph. And guys, you need to have that picture in your mind of each of these graphs. That's what a cos graph looks like. It also has a period of 360 degrees, and it also has an amplitude of 1. The amplitude is half the height of the graph. Okay, slightly different one is the tan graph, but exactly the same idea. It's positive in quadrant 1. It has an asymptote at 90 degrees. It's negative in quadrant 2. It's positive in quadrant 3. And it's negative in quadrant 4. So this is quadrant 4, this is quadrant 3, and it's got an asymptote here at 270, and this is 180, so I haven't drawn it very well. Guys, on a tan graph, a really, really important point is this point over here. At 45 degrees, a tan graph is at 1. Okay, now I'm going to show you a sketch which has got the different variations of these graphs, okay? So, just have to find it somewhere here. Right. So there's a vanilla sine graph. And you can see it's positive in quadrant 1 and 2, negative in quadrant 3 and 4. I'm only going from 0 to 360. If I went from 0 to 720, I would get 2 graphs because the period is 360. So two graphs. Okay, I'm going to go back to 360. If I add a number at the back, so instead of saying sine of theta, so sine of x, I add 1 at the back. What would happen to the graph? If I add 1 right at the back, just show me with your hands. It would go up by 1. Guys, look at this. If you add a number at the back, it just moves up. If you subtract a number at the back, it moves down. Exactly the same happens to a parabola or a hyperbola. Okay, if I add a number inside the bracket here, let's say I add 30 degrees, what will happen to the graph? It will shift to the left, guys, by 30 degrees. All right, it will shift to the left by 30 degrees. Have a look. There it goes. There's 30 degrees. And notice, if I shift it left by 90 degrees, I actually get a cos graph. Sine of 90 plus theta is cos theta. All right. So it makes sense. It always makes sense. Okay. Now, what happens if at the moment, the graph has a maximum value of 1 and a minimum value of -1. What happens if I change this 1 here, over here where this little hand is, if I change that 1 to a 2, what will happen to the graph? Show me with your hands. Well done. It will stretch it vertically. Guys, have a look at this. All right? It just stretches the graph up vertically. If I multiply by a number bigger than 1, it stretches it. If I multiply by a number less than 1, it actually squashes it. Okay? Cordwa, just be aware, if I've got a negative number, it also reflects it. So like, for example, negative 2 is going to be, it's not quite negative 2, there's negative 2. It's going to be a reflection, all right, and a reflection and a stretch. Okay, and then the last one that's not like anything else, it's not like any of our paper 1 functions. If instead of finding sine of 1x, I find sine of 2x, all right? Think about the sine graph normally gets to a maximum at 90, or with a maximum of 1. Now, if we multiply the angle by 2, what will happen is that it will get to a maximum at 45 degrees instead. All right. And what's been affected on this graph now? It's period. Okay. It used to take, the purple one is taking 360 degrees. The green one is only taking 180 degrees. The period is 180 degrees. Okay. So just, you probably haven't really got space on that page, but just to, I'm going to summarize this all for you over here. If you've got A sine B x B theta plus C plus D. Okay, this thing over here moves the graph up or down. Okay, it moves it up if D is bigger than 0, and it moves it down if D is less than 0. Does that make sense? If you add a number at the back. Okay. This number over here will move the graph left or right. It will move it left if C is bigger than 0, and it will move it right if C is less than 0. This number over here stretches or squashes vertically. Okay, so that's like this way, vertical, stretch or squash. Okay, and it will stretch if A is bigger than 1, and it will squash if A is less than 1. And then the very last one that we haven't looked, well, that we need to talk about is this one over here. This says that we're going to get B times as many graphs as usual. Okay, so for example, sine 2 theta, we're going to get twice as many graphs as usual, which means that the period will be 180. Okay, we're running sort of short of time, but I want you just to look at this question 2 on page, I don't know where the page numbers went on your document, because they are on my document. Guys, what graph is this? What sort of graph is it? Well done, it's a sine graph. So this is a 3-mark question. If you just write y equals sine theta, I'll give you a mark. I'll give you a mark because I know you know it's a sine graph. But this, guys, what has changed about it? Has the period changed or the amplitude changed? The period has changed, guys. How many graphs are we getting? We're getting 2. So this is actually sine 2 theta. Sine 2 theta. Okay, this doesn't want to change off. Sine 2 theta. Okay, what about this one? And I want you to look at, okay, I'm hearing someone say cos. Well done. All right, I want you to look, guys, to me it looks like the period is still 360 degrees. After 360 degrees, it's got back to where it was. What has, the 2 things that have been changed, maybe we can just take one last answer. Yes, just find someone. Guys, what is the 2 things that have been changed on this graph? So we're saying it's cos, okay? And we're saying that the period hasn't changed. Okay, has it, who can tell me what has changed? Right in the front row here. Thanks. The amplitude. So the amplitude's now 2 instead of 1. So how am I going to put that in the equation? Where must I put a 2? Over here? No. That will affect the period. Okay. If I want to affect the amplitude, this one over here is going to affect the amplitude. Okay. But now this graph has also moved. Someone close by there. Tell us how has this graph moved from a normal close graph? Guys, I'll tell you for nothing that this number over here is minus 30. So has this graph moved? How much? 30 degrees which way? To the left. Must I add 30 or minus 30 if I want to move it left? Add. Okay. All right. Guys, we're going to do one last, we'll do this one over here. Okay. What sort of graph is this? It's a tan graph. Okay. Its period is normal, guys, because it normally has the asymptotes at 90 and 270. Perfect. What has changed? Well done, the amplitude, because normally 45 degrees is at 1. Now it's at 2. So this is y equals 2 tan theta. All right. Guys, we're going to stop there. We haven't finished every question in the book, okay? And I'm not making any apologies for that because I want you guys to go away and work on it.